Here we are going to do LU factorization. What basically we'll be focusing is, given a matrix, we will apply the LU factorization to find the L and U for that matrix. So let's start with the theorem. So theorem is, if A is an M cross N matrix, and we can transform this to an echelon form without interchanging rows. Very important, guys. No interchanging of rows to do LU factorization. Then there exists an M cross M unit lower triangular matrix L and an M cross N echelon matrix U such that A is equal to LU. Okay, some observations. Not all matrices will have an LU factorization, and we can have more than one LU factorization for a given matrix. And if at any point in the algorithm we see the requirement of a row change, this is an indication that this matrix has no LU factorization. Let's do some examples. The first example is of this matrix A. It's a 4x4 matrix. We would like to apply LU factorization if it exists. Now, if there is an LU factorization, remember that the lower triangular matrix will be of the same size. It will be a square matrix and the same size as our matrix A over here. And U will also be of the same size, 4x4. Now, when we're going to create an L, what I normally do is I write down the elements which we're looking at. It's a 4x4. We have to make sure that there are only ones on the main diagonal. And it's a lower triangular. That means elements which are above the diagonal matrix are just a bunch of zeros. We are going to find what these little elements are below the main diagonal. So let's start with it. The very first thing you do is we look at the very first column. Now, and match it, we look at with the column of A. Now here it is not 1. So what we do normally is we will go ahead and make this 1 by dividing this whole pivot column by the first element 2. So when we divide this element by 2, we get the element of the first, the column for the L matrix, the first column, which will give us 1, minus 2, 3, and 1. So we have been able to get the first column. Simultaneously, we will find U. In order to find U, remember it is an echelon form of this matrix. So what we do is we apply this algorithm. And in this algorithm, we will apply the so you're going to make this should remain non-zero. We're going to make these elements to be 0 elements. And we apply these 3 row operations on the row 2, row 3, and row 4. When we do these row operations, we get this new matrix A1, which is an equivalent matrix. Now that is the beginning for our U. We have not yet done it. Remember, we have to make this the whole matrix into an echelon form. That means these 3 terms, 1, minus 4, 29 have to be 0. Okay, so this is our first procedure, is find the matrix A. We get the first column of the lower triangular matrix, and we're able to get the first column in the echelon form for the U matrix. Now we look at A1, and we will now go and create. Now remember, this has already been taken care of. Now we are going to look at the next column here. So over here, what we're now going to do is we are going to go and look at the second column of A1. And remember, guys, that we have to make this to be 1. Okay, this one is just the page number. So now to make this to be 1, remember this has already been done. This is 0. So you divide this whole column below, from -1 and below, by -1. So when you do this one, we get 1, -1, and 4. And we have yet to fill up these ones. Remember, this will be 0, 0, and all those things. So once we get the second column of the lower triangular matrix L, now we go back to the row A1 matrix and do our row operations and get the second column of the upper triangular matrix. And remember, we are trying to create an echelon form. That means we are basically going to make these elements to be 0 elements. So we apply these two row operations and we get this new matrix A2. So we will just continue with the process we did on A1. We'll do it on A2. We'll find L1. We'll go get the new matrix of that. We will continue till all the columns of the lower triangular matrix are filled up. Okay, now let's look at step 3A. In step 3A, we are now going to make this element to be 1. And that is, remember, these two are already taken care of. We get these to be 0. We divide this by -3. And we get 1 and -3. And similarly, we will apply the row operations on A2, this matrix A2. And we will get our next matrix A3. Now, this, if you notice, is already in the echelon form. So we are basically done. Now we have to fill up this column, remember, because this has to be 1 by default. Okay, so notice our A is now all these matrices, and we just simply write 1, and this is the new matrix U. So our A matrix is now written as L times 0. Now this was a square matrix, so we would like to now try an example on a rectangular matrix. Okay, let's go ahead and look at a rectangular matrix. That's example 2 for us. Now let's look at this one. This is a matrix A. First of all, we have to make sure that what would be the size of the lower triangular, what would be the size of the upper triangular. Now remember, the lower triangular matrix is a square matrix, and the size of the lower triangle depends upon the number of rows of the original matrix. Whereas the upper triangular matrix, the U matrix, depends upon the size of the original matrix. So if it's a 3 by 5, we're going to have a 3 by 5. If it's a lower triangular, this one depends only on the number of rows of the original matrix. So what we normally do is we do, if the first example we went step by step, but in this one we just can do it together. So what we normally do is we write this matrix. As we go by applying row operations, simultaneously we write down the elements for the lower triangular matrix. Okay, so let's start. So this is my original matrix. Now for the lower triangular, remember 3 by 3, we want 1, 1, 1, 0, 0, 0. To get the columns of the first one, what we do is we look at the very first column of the original matrix and look at the very first element, topmost, of the non-zero. You divide this whole element by this element 4 here. We get 1 minus 4, 2. So we are taking care of the first column for the L matrix. Remember, this is L, guys. Okay, now we apply the row reduction algorithm. We get this matrix. Now what has happened? Minus 3 zeros. So now we have to go and look at which is the which is the non-zero column which appears first after we have made the changes in the first column of this matrix A. So this is the matrix which we have to look at. Sorry, this is the column. Okay, that will make the column for the second column for the lower triangular matrix. Now remember, we do not look at the topmost. We're now looking at this element because 0, this is the one, the last two elements are the one we're looking. This is always going to be 0 by the way lower triangular matrix are created. Now that means we look at this non-zero term and you divide this non-zero term because this is the pivot element. The whole the column beneath it, not above, beneath it by minus 2. We get 1 and 5. And then we go ahead and apply the algorithm. And when you apply the algorithm, this is exactly in the upper triangular form. Do you see that word? So this is the upper triangular matrix. We can't go ahead and do anything beyond it. And automatically this will be 1. So here is our LU factorization of the original matrix. Okay, let's go ahead. Now do one more example. Now this example, we have a 5 by 3 matrix. So when we write down a lower triangular, now keep in mind this size of the lower triangular depends upon the number of rows of the original matrix. And the upper triangular matrix is totally dependent is the same size as the original matrix. So the very first thing we should be doing is we should be writing down the lower triangular the way we need it. We need 1, 0, 0, 0. Then these are the elements, these little dashes are the ones we have to fill. So in order to do that, what we are going to do is we're going to apply the row reduction algorithm on the matrix A. And as we move, we write down simultaneously elements for the lower triangular. Okay, let's continue. Okay, so this is remember you have to fill up this column of the lower triangular matrix, the first column. To do that, we go to the original matrix A and look at the first element. If it is non-zero, you divide the whole element by that 3. When you do that, you get 1, 3, 5, -2, -1. So this gives us the lower triangular matrix first column. And simultaneously, we go apply the algorithm. And now, when you get this algorithm, we get this new equivalent matrix. Now we go back and look at what is the next pivot column and the next pivot element. So this one, remember, I just forgot, you divide by 3. Here, you're going to divide this by -2. We don't do anything on the top, guys, remember, because this is always going to be 0. So you divide by -2, the column, elements from -2 till down. And then you divide, what you get is 1, 2, 0, -2. And as you're doing it, now remember, this is going to be important. This is going to be a 5 by 5 matrix. Now we continue and apply this algorithm. We get this new matrix. Now this is already in the upper triangular form. Now remember, when we have -4, so now we have to still work on this one, because this is the next pivot column and -4 is the next pivot for us. So this is going to give us the element for the third column, elements of the third column for the lower triangular matrix. We divide this, the whole column beneath, from -4 down, and get the terms for the lower triangular matrix. So you have 0, 0, 1, -1, and 2. Now remember, in a lower triangular matrix, guys, this is filled by default, because now here this term, because we can't go further. Do you all see that over here? We can't go further. So just go ahead and fill up the columns of the identity matrix of size 5. So these 3 are already filled up, but when we moved around applying the algorithm. And the last 2, you just go ahead and fill up the identity columns of an identity matrix of size 5. Okay, now this one, we have to make it in the echelon form. At this point, it's not in the proper echelon form. I just want to, rectify the mistake I made earlier, because these 2 are non-zero. So what you're going to do is we're going to make this 0 by applying this row reduction algorithm. So this is the correct upper triangular matrix, guys. So this is our final answer, A, which is in terms of the lower triangular matrix, and the upper triangular matrix, which is in the echelon form. Okay, now let's look at an example where the LU factorization is not possible. Now, when you write this matrix as a 3 by 3, remember the lower triangular is going to be a matrix with ones on the main diagonal and then the upper triangular. So as we start doing it, what happens? When we apply this element, we apply the row reduction algorithm, we get a matrix like this. Now remember, we have to have an upper triangular in the echelon form, which can only be possible when we interchange these two rows. And this is one of the biggest conditions that LU factorization does not allow interchanging of rows. So the moment we come across this scenario, we say this matrix A has no LU factorization. And guys, keep in mind that after looking at these two videos, please go ahead and do these problems, which I have already uploaded for you guys. Questions 7 till 12. They are taken from the book. So go ahead and practice these problems. Thank you.